challenge is called Vowel Remover. You are to create a function called shortcut to remove all the lowercase vowels in a given string. They have a couple examples here. Consider Code Wars input and notice how it returns basically Code Wars with the OEA removed. And the same thing we see for goodbye. The O's are gone, the E's gone, but notice the Y persists because it's not considered a variable for this challenge. They probably should have noted that, but they kind of implicitly did it with this example here. So we're looking at your standard A, E, I, O, U for the vowels. Go ahead and pause the video and go ahead and solve this one. Come on back when you're ready. I'll go over 2 solutions. So first, let's do one using some LINQ methods. Probably would have guessed that by now if you've been watching this series. And then we could make a list. So since I'm going to be using the list collection type, do you remember which library you have to bring in for that? System collections generic will give me access to list. Mine will be of char, right? A string is a collection of chars, characters. We'll call it vowels, and we'll make that a new list. We'll use these curly braces to populate it. I'll have A, E, I, O, and U. They told us not to worry about uppercase. If you did want to worry about uppercase, you could basically copy them all out again in uppercase form. Unless you were going to manipulate the input to be all lowercase so you didn't have to worry about it, you could do that too. But I'll keep it simple here. We'll use the lowercase letters. And then we can get into some LINQ. We'll return input, right? We know our input's a collection of chars. So we had a LINQ method we've used at least a few times now that sort of acts as a filter. If you remember that, it's called where. And what that will do is, as we go over each character in the input string, it'll apply a condition. If the character meets the condition, it sort of gets passed through. If it does not meet the condition, it's sort of filtered out and removed. And remember, this whole thing will generate a new collection of characters that all meet the condition. So what would the condition be? Well, the condition is if the character is a vowel, throw it out, otherwise keep it. So we're going to use a lambda, and our parameter name, I like to use ch for char. You can call it whatever you want. You can call it letter, Actually, letter sounds nice. Let's mix it up. Letter, where the vowels list, do you remember lists have a contains method? And this will say if vowels contains the letter, we actually want the negation, the opposite of that, right? We don't want to allow vowels to pass through. So I put this exclamation mark, and that essentially inverts the logic. So it's basically saying where the letter is not a vowel. It's not contained in vowels. And see, if you pick good variable names, it almost kind of reads like English. Granted, it's in a weird order, but, take the input where the letter in question is not contained in vowels. And as you get kind of used to this, it becomes very clear, and it's nice to look at and work with. I guess I'll have to take my word for that if it looks really ugly now, but we'll move along. So, like we said, where we got our condition in there, and this is going to return one of those generic collection of characters. But remember, our contract here says we have to return a string. So we've had this issue in the past where we had to make a string out of the collection. And to do that, we know that LINQ collections have this handy to array method. right? This will convert that sort of I enumerable of char into an array of chars. And then we know that the string constructor can work with an array of chars. It can construct a string from that. So I'll do that. Turn new string. And I think that covers it. Feel free to go back to the docs. We've pulled them up in previous challenges, but if you don't recall, just want that refresher, you know where the Microsoft docs are by now. C#, any of these, where, to array, string, constructor, and check that out. Let's make sure I did this right. Okay, good deal. They'll let us submit. So that's one way about going, or I'm sorry, one way of going about it. I said I would show another solution, and for this one, we'll use our old friend, regular expressions. Do you remember which library to bring in for that? System, text, regular expressions. That should be it. And we're going to use it in a little bit different way than we have before, so I will pull up the doc page on this one. Notice that the regex class has a replace method, and there are a lot of overloads here. Don't be intimidated. Some of them are wordier and do more than we need. I'm going to take this simplest overload here, and we'll use that. In a specified input string replaces all strings that match a regular expression pattern with a specified replacement string. So that sounds useful to us, right? If we make a pattern that holds vowels, and if we make the replacement string an empty string, that effectively removes vowels, right? So let's try that, and let's check out an example. Like I said, these examples are really helpful for when the text just isn't doing it for you and you need to see it in action. So we have, notice this, we're gonna make an instance of a regex class here. We're gonna make an object, a regex object, and we're going to construct it with a pattern that we make. In our case, we're going to make this pattern collect vowels or specify vowels. And then once we have that regex object, we can call this replace method on it. We'll pass in our input that we were given in our challenge. And then for replacement, you can just put empty string. So let's try that. So we got our system text regular expressions. Let's make one of those regex objects. Equals new regex. Oh, but remember we were going to construct it with a pattern. So let's do that first. String pattern. We've talked about patterns in other videos, and if you recall, we can specify characters to match. And we can do that with these square brackets. And inside, I'll just put the characters I want to match. A, E, I, O, U. Remember, it can match them in any order. It doesn't have to match all of them. It can match one of them. That's how this works. If you were worried about capitals, you could add those in here too. I guess I'll leave it in this one. Shouldn't matter. So yeah, there's our pattern. Now let's make that regex object with pattern. And once we have that, remember what they did. They said, well, we can return in this case. Return regex replace our input. We even have the same variable name for our input as they did in their example. And then we should be able to specify, what was the replacement string. That's right, replacement. And we mentioned replacement, empty string. So it's going to find characters matching any of these values. If it finds them, it's going to effectively delete them by replacing them with an empty string. So let's run that. Looks good. And then if you did want to condense this, you could probably do something like this. Still looks good. And let's see. I wonder, for you one-line Wallies out there, could you do this? Yeah, looks okay. So I didn't go right into this. This, might look ugly. Imagine had we just started there, it was easier to see broken out into the stages, build that string pattern, create a regex object, and then you can call replace on that and return it. So yeah, this is fine too. I'll go ahead and submit mine that way. And yeah, certainly other ways of going about this. You could have done a traditional for loop. It's a little bit ugly. You're at each step of your loop, you're checking if character equals A or if character equals E, etc. But that can be good practice, like I've said, if you struggle with that and are still getting comfortable. So yeah, hit me up with those solutions. Any questions? I'll take a quick peek at what else is out there. Regex. Okay, so this is another way of doing it. String concat, where that's kind of similar to what we did in the first solution. Yeah, what you might expect. It's a lot like what we did. Okay, yeah, I'll end this video here. Thanks for watching.